So yesterday we were differentiating logarithms into fractions. So today is going to be the opposite. We're going to be integrating. So that means we're going to have to start out with our fraction, where we have the function on the bottom and the derivative of the function on the top. And if we can get our integral in that form, it will integrate back into a logarithm. Now, one of the things that you've probably noticed straight away about the logarithm is that there is absolute value signs around the function. This is just because we know that logarithms, like the ln of x, only exist for positive values of x. Okay, so we have to make sure that whatever that function is, we take the absolute value of it to make sure it's positive so that we can actually find solutions. Okay, all right. So the top formula is the one that is on your reference sheet. However, this is a simpler version. This one's not on there, but this one is one that should almost be automatic. If you are integrating 1 over x, the derivative of x is 1, that's the one that integrates to ln of absolute value of x plus c. Okay, but same formula really. All right, so question number 1. Find the definite integral of 1 over x dx between 1 and 2. Okay, so integrating 1 over x, that was this formula just here that I had, right? So derivative of x is 1, so I can integrate that straight away to be log of the denominator, which is log of x. So I'm going to put it in square brackets because it's a definite integral, and it will be ln of the absolute value of x between 1 and 2. Okay, then we sub in ln of sub in 2, and the absolute value of 2 is just 2 because 2 is positive, so ln of 2. Then minus sub in 1, ln, and the absolute value of 1 is 1, so 1 like that. Okay, what is ln of 1 equal to? 0. Okay, so that's nothing. So our answer is just ln of 2. Okay, you can put a little note in here that this equals 0, just in case you forget. All right, so that logarithm, that little space over here, is equal to ln of 2. Part B, approximate the integral, correct to 3 decimal places, and verify that my integral is between a half and 1. Now the half and the 1 is coming from this diagram up here. Remember when we first did integration, we did it by approximating using areas of rectangles and triangles and stuff like that. So I'm after the area between, actually let's blow that up. I'm after the area between 1 and 2 and that curve. Okay? Now, using the rectangles, if I make a smaller rectangle, that one there, the smaller approximation for that area would be A equals BH, the base is 1, and the height is a half. Okay, so 1 times a half is a half. The area of that red rectangle is a half. Okay, that's the lower part. If I go to the big rectangle, which is overestimating my area, A equals BH again for a rectangle, base times height would be 1 times 1. The purple rectangle has an area of 1. Okay. So that's where they're getting, where is my thing? These numbers here, between half and 1, because the red one was a half and the purple one was 1. The real area is somewhere in between that. because my curve is floating in between those two rectangles, correct? So let's just confirm that our ln of 2 is actually somewhere between 1/2 and 1. And all we're doing is using our calculator. So ln of 2, type it in your calculator to 3 decimal places, is 0 point, are we awake? Everybody awake today? 6, and then, where's the calculators? 0.693. That's between 1/2 and 1. Yeah? So we can see the decimal, and then I'm just going to say, hence, the real integral of 1 and 2 of 1 over x dx is going to be between 1/2 and 1. Okay, I saw my rectangles with the 1/2 and the 1, and this area, which I found up here, is in between it. That's all it means. Okay, question 2. We're now going to go into lots of integrating practice. So question 2, we have definite integral between e and e squared of 5 over x. Okay, start with the bottom. The bottom is an x. That means that I need the derivative, just write that down again, the derivative of x on the top, which would be a 1. I didn't have a 1 there though, I had a 5. All I need to do is just slide that 5 out the front of the integral sign, like that. That's the same thing, isn't it? Moving that 5, well, not with that line there, but moving that 5 out there, but I've rearranged this part into the part that will integrate into a logarithm. Yes? So it becomes 5 out the front of ln, absolute value of the denominator, which is x. And this is a definite integral, so we're going to put that in brackets between e and e squared. Okay, then we sub in 5 ln, e squared is positive, so that's just going to be e squared there. Then minus 5 ln, e is also positive, so my absolute values aren't doing much at the moment. Sorry, can I tidy that up? I could, yes, lots of good suggestions there. Maybe let's bring the 5 out first. Ln of e squared minus ln of e. All right. What's ln of e? E to the power of what gives e? 1. So that's equal to 1. What is this one equal to? 2. So this is 2 minus 1. So that whole bracket's just equal to 1. So the answer is 5. And that's it. All right, question B. Let's get it in the right form first. So starting with the denominator, I have 1 minus 2x. I need the derivative of the denominator on the top. So what's that got to be? Negative 2. Now, I had a 1 there. So how do I fix it to be the same value? Negative 1/2 out the front. Okay, sorry, it's a bit small. Hope you can see that. All right, then we can integrate. We are going to leave the negative 1/2. We're going to become ln of 1 minus 2x in square brackets between 1 and 4. Okay, subbing in minus 1/2. If I sub in the 4, I get 1 minus 8 in here, which is minus 7. And then I'm doing the absolute value of that. So it becomes a positive 7. So that'll be ln of a positive 7. Okay, then minus. sub in 1. Actually, we have minus minus, so that'll become a plus, half, ln. Sub the 1 in, will be 1 minus 2, negative 1. Absolute value of negative 1 is positive 1. Yes, good. Okay. Let's factorize out a negative half, because then I would have ln of 7 minus ln of 1. What is ln of 7 minus ln of 1 become? Say that answer. ln of 7, because that's just equal to 0. Okay? Or you could use log laws as well. Log subtracted would be 7 over 1. So it's just ln of 7. So the answer is minus a half ln of 7. H. Question C. Integrating. We need to make sure the derivative, whatever's on the bottom, what's the derivative of the bottom? 1 is on the top. It's already in the right form. Lovely, no fiddling needed. So I can integrate it straight away to be ln absolute value of x minus 2 between 5 and 1. Okay? Sub in, we will have ln of 5 minus 2 is 3. Absolute value of 3 is 3. Minus ln of 1 minus 2 is minus 1. Absolute value of minus 1 is 1. What is the value of ln of 3 minus ln of 1? Just ln of 3. Very good. Now, you may notice, if you're super observant, there is a tiny little star there. Because even though we have done the process, this integral has no meaning. Because this equation here that I've started with would have an asymptote where? X equals 2. And I'm integrating from 1 to 5. I'm trying to integrate over an asymptote. Can't do that. Okay? So while the calculus part works, the actual value of that number wouldn't represent a real area or anything like that. Okay? Because we've integrated over an asymptote. So let's put a little note in there. So we'll just say, however, this definite integral is meaningless as it crosses an asymptote at x equals 2. All right, let's try D. What's the derivative of the bottom? 2x. Ooh, it's perfect. So we can integrate it straight away to be ln of the absolute value of x squared plus 2 between 0 and 1. Okay, let's sub in. ln of, sub in the 1, we get 1 squared plus 2, which is 3. Good. Minus, sub in the 0. Good. ln of 2. How can I make this nicer? Log laws. ln of 3 over 2. Done. Next. E. Sorry, did you write that down? Yep, good. All right, E. Integrating. It's not quite perfect this time. We're going to need some fiddling. We have 9 minus x squared. What's the derivative? A negative 2x. Okay, I had the x. I've multiplied it in a negative 2, which means what do I do to compensate? Times by negative a half out the front. Okay, then I can integrate the negative a half, then ln of absolute value 9 minus x squared between 4 and 5. Okay, let's sub those in. So negative a half ln, sub the 5 in. 9 minus 25 is negative 16, but absolute value positive 16. Then minus actually, so plus half ln, sub the 4 in. 9 minus 16, negative 7, so positive 7. All right, can we tidy this up? We could keep that half out the front. What can I do with the 16? 16, if I really want to... yeah, you're on the right track. 16 is 2 to the power of 4. So just reducing it down, I could make it a smaller logarithm. Minus ln of 7. Then you bring the 4 down, so it's 4 ln of 2 minus ln of 7. Or I could have just divided it from the start. Anyway, but if I times the half back in now, half times 4 is negative 2 ln of 2 plus a half ln of 7. There's probably other things I could have done. I could have tried to put them together in there. But just be aware you'll have to fiddle potentially to get to the solutions in the back of your textbook using your log laws. What's up? Oh. All right, let's go on to F. Is it in the right form? Not quite. What is wrong with it? The minus. Yeah. So the derivative of this is 3x squared. Negative, sorry, 3x squared. So I'm using the negative up here. So rather than rewriting it, let's just go, I need a minus there. So minus out here. When I integrate it, it would be negative ln of 1 minus x cubed between 0 and 2. All right, sub in, we have negative ln 1 minus 8, because 2 cubed is 8, is negative 7. Absolute value of negative 7 is 7. Is everyone okay with me doing these bits in my head? Yeah, you know what I'm doing? Good. All right, then minus minus makes a plus. ln 1 minus 0 is just 1. ln of 1 is nothing, so it's just minus ln of 7. But, what makes the denominator 0? Anything? And x equals 1. Where have I integrated between? Yeah, so we have another one. We have another one where we're integrating over an asymptote. So yes, we can integrate it, but again, this one is meaningless. So this is meaningless as it crosses an asymptote at x equals 1. All right, question 3. Yes? Yeah, if it's just telling you to evaluate an integral, we can still do the math part. But if there's ever any further in depth on it, you need to act like if this was I've got a diagram, I'm trying to find an area, you can't integrate over that asymptote if you're actually after a proper measurement of the area. Okay, question 3. Find f of x if the derivative is 2 over 3 minus x. We are also told that the graph passes through the origin. Hence, find f of 2. Okay, so this is one of those ones where you go from the derivative to go back to f of x means that you want to integrate the derivative. No, change it. Okay, I want. Sounds selfish, doesn't it? I want. On top, what do I want? -1. How do I change that from a 2 to that one? I need a hat up there. Yeah, so the 2 is going to slide out the front, and I put a minus sign on it because then it becomes back to a plus. Yes? Okay. All right, now I can integrate -2 ln of 3 minus x. This is an indefinite integral. What do I need to remember? Plus c. Okay. All right, then, once I have this, I'm told that it passes through the origin so that I can work out my constant. I'm going to sub 0, 0. Okay, so y is 0, x is 0, and then plus c. So 3 minus 0 is just 0. 3 minus 0 is just 3. Absolute value of 3 is still 3. Plus c. So moving the log part across the other side, we would get c is equal to 2 ln of 3. Which means that I'll do it over here. I've moved that term across to the side. So it means that my function f of x is -2 ln of 3 minus x, but instead of plus c, I now know that the c is 2 ln of 3. Not finished, because once I've found that, I hence need to find f of 2, so I can sub that in. F of 2 equals -2 ln of 3 minus 2 plus 2 ln of 3. All right, 3 minus 2 in the absolute values here is 1. ln of 1 is 0. So this whole thing here is just 0. So my answer is just 2 ln of 3 again. Okay, now we're done with that question. All right, what else we got? Question 4. Product rule. Question 4a. Differentiate. Now this is meant to be integrating, but sometimes we differentiate things first because then we can integrate and know how to go backwards. Okay? So this is a product. We are going to do our u and our v. Okay? Now u dash will be 1. V dash is 1 over x. Good. All right. The product rule. It's not y equals, so I'm going to call it d over dx. It's my derivative. And we're using VOOV. Okay. So v times u dash will be log base e of x plus u times v dash will be x times 1 over x. Or in other words, just 1. So it's log e of x plus 1. All right, so I've differentiated. Part B, show by differentiation that x log e of x minus x is a primitive of log e of x. Okay, so show by differentiation. So that means I'm starting with x log e of x minus x. I'm calling it y because that makes it nicer for me to differentiate. So y dash equals the x log e of x. To differentiate that was what I did up here. Don't do it again. Just replace the x log e of x with log e of x plus 1, because that's what its derivative is. So log e of x plus 1. That's this first part differentiated. Then I differentiate the minus x, which is negative 1. So plus 1 minus 1 is just the log e of x. So what have we just found? If I differentiate this, I get to that, log e of x. So primitive of log e of x, so primitive is integrating. So if I integrate that, it's going to go back to what I started with. Yeah? So what it's trying to say, okay, reversing the result is if I wanted to integrate log e of x dx, because we don't integrate logs. We integrate fractions that become logs, but we don't have a formula that tells us how to integrate logs. Okay? But I've just found one that works for this one. Okay? Integrating log e of x will be x log e of x minus x plus c if it was an indefinite integral. Okay. Use, part C, use this result. Use that to evaluate the integral between 1 and e of log e of x. Now, if you were sitting in a test and we hadn't done A and B and it just said to integrate this, you would be in all sorts of problems. We don't know how to integrate the log, okay? Only because we have differentiated can we go reverse the process, go back to the original, okay? So, integrating the logarithm, which is this is the log, integrating the log is going to go back to that, okay? So it's not a formula, it's only because I found it earlier. So integrating becomes x log e of x minus x between 1 and e because it's a definite integral now. All right, sub in e log e of e minus e. Oh, that's a lot of e's. Okay, then minus, I'm going to put this in brackets, 1 log e of 1 minus 1. Okay. E log e of e. All right, what's the log e of e? 1. So that's just equal to e. Then I have minus e. What's log e of 1? 0. So then it's minus 0 and plus 1 because I'm the minus 3. Spend the bracket out. So e minus e is nothing. The 0 does nothing. The answer is 1. Yay. Oh. Come on, that was a nice answer. All right, we made it to the end of 6i.